Okay, so we'll start with Jenkins. So before going into Jenkins and installation, so let us try to understand what is software development lifecycle, what is continuous integration, continuous testing, continuous deployment, continuous monitoring. Okay, CD means there are two terms. One is the continuous delivery and one is the continuous deployment. Okay, so there is one small difference between them we are going to see. Now imagine you are asked to develop an online shopping application. Probably you are the the first developer who is going to start working on this project. So this is the task. You are asked to develop an online shopping application. So we are talking about the only on the high level, so we won't talk about creating a project in Jira or getting all the requirements from the customer. So we are not going to talk at that level. So we are going to talk about the only the tools that we have learned so far. So what generally we do, we create a GitHub project, and then basically we'll add all the collaborators. Like if there are three developers working on three different kind of features, so all of them has to be added as the collaborators, so that they will also get push rights to the project, right?
Mhm.
And then for working on this project, so each one will create their own branches in their local repositories, and once they find that the branch can be pushed to the remote, so they will push those branches to the remote repositories. So everyone will push the branches to the remote. So now if I wanted to take his changes, so I can just pull those changes into my local repository. So this is how our Git work. We already seen this in Maven. Software development is not a very small process, so it has to go through a lot of stages, right? So what are the lot of stages? First you have to start writing your code in an IDE, get all the dependencies from the central repositories, and then we'll compile our source code. Then we'll pack into the binary, run some test cases, and then package them either as a as a war file or a zar file. We can also package them as a container images, like the Docker images. And then once these container images are ready, so we have to push them to the central repositories, right? So like the Docker hub, or you can set up your own repositories like the Nexus or the JFrog, right? So that other people can download your dependencies or the Docker images for the deployment. Okay, so basically, so this is not a one-time process, right? Because we are following a agile process. That means that we release every now and then. Okay, so we have the sprint cycles. So we'll come back to all these later. Okay, so what is a sprint, what is an agile process? But basically, so instead of spending 6 months of time working on a project and then releasing, so we'll release our software every 2 weeks or 3 weeks, right? And then we'll test that software. Okay, so in this process, even if there is a requirement change, so we can easily adapt to that and requirements, right? Because after 3 weeks, when we are getting a new requirement, so obviously you can work on those new requirements. Okay, so this process is a continuous cycles. Okay, so you cannot do it manually. Basically we will opt for the build automation tools. Okay, so what are build automation tools? So they does this compiling, down dependency management, packing your software into a distribution format like jar or what. So these are all the build automation tools. So build automation tools are, they can help us to a certain extent. Okay, like the Maven or the Gradle. So we have all these build tools, right? And now let's say that you have finally developed your application. Okay, but what about the testing? Okay, deploying or delivering it to the end customer. Okay, so even this process has to be automated, right? So it is the process is not only till the development of the application. So the process has to move forward even with the testing, even with the delivering to the customer, or deploying it to the various environments like the dev, prod, pre-prod. Okay, whatever are the names that we use in the organizations, right? So this whole process has to be automated. Okay, and one more thing is, it is always better to fail faster and often. So why I'm saying fail faster means, if you're failing faster, then you are going to get time to fix bugs in the early stages of the development. It is not like that you developed a feature taking 6 months of time, then then you found out that that feature is not needed, then your 6 months of time is wasted, right? And also, if the software is failing faster, that means that you developed a piece of code now. So when you try to deploy it, so that code is not working, or it is failing some test cases, so immediately you can work on those fixes in the same on the same day or the next day, right? So instead of you failing in the production, you fail faster in the development stage itself. So now, what are the various stages of the DevOps? So we have the continuous development, okay, continuous testing. So where we continuously test our source code. That means that whenever you push your source code to the repositories, so immediately it has to be tested. Okay, it is not like you test once in a month or once in a 2 weeks. It's not like that. Okay, so every time you do a push, it has to be tested, and then it has to be integrated with the other other modules of the project, and you also have to do the integration testing, and then this has to go into the deployment. Okay? And once it is there in the production, we have to continuously monitor it. Okay, if you're not monitoring, you will not know how your application is performing in the real time, right? So these are the various phases of the DevOps. So modern software moves fast and demands more from the developers. Okay, so what this means is, so we have to release the software very frequently. We have to keep on changing the requirements according to the customer. Okay, so there are a lot of demand even from the customer side as well. So tools and concepts around CI/CD, okay, help developers deliver value faster and more transparently, because he cannot spend time testing his source code, developing, testing, and then deploying them manually, because even if the change is small, it has to go through a lot of stages, right? The compiling, deployment, etc. Okay, CI/CD revolves around basically three major processes in the development of the software or the software development life cycle. So one is the build, the other one is the test, and the other one is the deploy. So build, we are calling it as the continuous integration, where we continuously integrate the source code, and then we continuously test it, and we continuously deploy it. So
Yes.
now understand what is continuous integration. Okay. So what is continuous integration? So as the name itself suggests, it is integration. Okay. So we are integrating the code. Okay. So now, being a very good, very big project, one cannot work on the project alone, right? So there will be a lot of developers. Okay. So a lot of other engineers working on the project. Okay. So they use their own branches, and then they'll push the source code, okay, into the repositories. Okay. So now, what makes the complete application? It is not only his source code, right? Even his source code is needed, his source code is needed, everyone's source code has needed. So every time when someone pushes the source code, okay, so what generally generally should happen is, so we have to integrate the source code. What is when we integration? So we'll take the other's code, or take the current snapshot in the Git repository, and then we'll run the build process, right? Build, test, and analyze. So we will also analyze the test results and all. So this complete process is known as the CI process. Okay, so there are many people, they are checking into the source code repository like Git. So when you have the changes in the Git repository, we will have a CI server like the Jenkins, or any there are a lot of CI servers. Then what the CI server will do, it will take the current source code which is there in the Git, and then it will run build, test, and then it will also send the result. So if you are also configuring the result sent back to the the developer, so what you can do is you can simply send it back to the developer like this. Okay, so let's say that the test failed. Okay, so one test is failed, so what we can do is we can immediately send an email back to the developer who checked in that code. Okay, let's say, so I checked in a feature. Okay, I was working on a one feature. Okay, that feature is like maybe downloading, giving a download option for a PDF file or whatever it may be. So I push the changes to the remote repository. So once this remote repository gets those changes, immediately CI server kicks in. It will take this source code into its own server through git clone, Okay, and then it will run the build commands, test and result. Let's say the test case is failed. Okay, then immediately it will send the response back to the developer that this particular source code has failed. Okay, so continuous integration, so one thing that you have to understand is, so continuous integration is not for the getting rid of bugs. Okay, it is for the detection of bugs at the earlier stages of the development. So the benefits would be fixing bugs quicker and faster, and you will have more frequent releases. So basically, generally how the CI process works, what happens is on each pull request. Okay, so if I have to, okay, there is a master, there is a dev line, and let's say that from here there are some features coming up. Okay, so someone branched out from this point, they are working. So this is one developer. So this is one more developer. Okay, he's working on feature 2. Okay, so now feature one branch, so developer is committing a lot. Okay, he is committing in this branch, and this guy is committing in his own branch. Okay, so now when this CI process should trigger, okay, from where it has to trigger. So let's say this feature is properly tested by this developer, okay, in his local machine. Now he created a pull request to the development branch because he wants to merge the changes back to the development line. Now, once this PR is raised, pull request is raised, this point, what we can do is we can run the CI pipeline. What the CI pipeline will generally do, it will whatever is the feature branch that he has, right? So it will clone that branch, it will build, test. If test cases are passing, then this pull request is closed. Okay, then his changes will be merged to the development line. Then this branch will be removed. Now feature 2. So this guy thought that his changes are completed. Again, he'll raise a PR back to the dev line. So this is about the merge commit that is going to come. But when it will come, once you raise a PR in the GitHub, automatically through webhooks, CI pipeline will be automatically triggered. CI pipeline will build and test. So once test is done, so you can send an email back to the developer or someone who is reviewing. So once he finds that the test cases are passing everything, so what he can do, he can go ahead and close this pull request. So this is PR based. So what are the other types? So there are a lot of types, right? So I can also invoke a CI pipeline every time I push to my own branch. That is also there. So I'm pushing to my own branch. At that time also I can create a CI pipeline. It is up to me. Okay, or else when I'm merging to some development branch, then I can invoke the CI pipeline. Basically, this is what we generally do. Okay, so why pull request is needed is, see, one cannot merge into the development branch just like that. Okay, he has to create a PR, then CI pipeline has to do all these build, test. Once it is successful, then only this PR will be closed. Otherwise, what will do? This PR will be rejected. Then the development has to make some more commits fixing those issues. Then again he'll create a PR. Yeah, so that is a continuous integration. But what about continuous testing? So continuous testing is also an important thing. So continuous testing is a software testing process that involves testing in every point of the development cycle. That means, so whatever test cases you are writing or whatever the source code you are writing, so those source code should not have any known vulnerabilities or anything. So your test cases should pass, your whatever functions or methods you are writing, they should work properly. Okay, so these are all the continuous testing. So even you'll also scan your source code with the sonar cube. Okay, we'll come to the sonar cube. Okay, so this is the continuous testing part. So every time, so once you build your the source code, you have to run the test cases on it, so to see if the test cases are passing. Okay, and depending upon the the output, then only we can go ahead with the continuous deployment. Without testing, nothing should go into production. Okay, so what are the various test cases you have? We have the unit test cases. So unit test cases are the test cases for individual methods and functions. Okay, so we'll have the methods, we have the functions, right? So we call functions as methods. Basically, those are two different terms that are interchangeable, but usually functions and methods does the same work. Okay, unit testing means we are testing individual functions. Okay, but what about the integration testing? So integration testing means you will combine every module as a whole project, and then we'll run those test cases. Then UI test cases. Okay, so whether how the UI is working, okay, it is working perfectly fine or not. And then acceptance testing. Acceptance testing means, so we'll see if the software is meeting the business requirements or it is not yet ready for the production. Okay, so there are a lot of test cases. I just mentioned only four. Okay, there could be tens of test cases. Now what is continuous delivery?
Yeah.
Okay, so this is extension of integration. So you have integrated your source code, you built it. Okay, you containerized your source code, or you created a jar or war file. So what you have to do, you have to deploy it, right? You have to deploy it to the real server, and then do the other forms of test cases. Okay, so automatic deployment of all code changes to a testing QA environment, staging, or the production. Okay, so this is known as continuous delivery. Okay, but these delivery often will be managed by someone known as a release manager. Okay, so he has to approve the continuous delivery process. Okay, it is like, so we are delivering our final artifact. So if you see the the image, so what is this image? We have the CI/CD server sitting in the middle. Okay, and then we have the Git. So basically what we'll do, we'll clone it into the CI server, we'll build, test everything. So this is the integration part, right? So once integration is done, we have the CD part where the build artifact will be either containerized, okay, and run it as a container, or you can copy that into a server like a Tomcat server for the deployment. Okay, even in the CED part, so if the deployment is successful, you will send an email that deployment is successful. If the deployment is failed, you can say that deployment has failed. Continuous deployment, it is a one step further of the continuous delivery. Here all the changes that pass the verification steps, right, are released to production. Okay, automatically. So this process is completely automated. This is also known as customer release. Okay, so deployment means, you should say that it is just like your customer release. Okay, so delivery means you're delivering it to various environments like testing, QA, staging, or production, like that. So what is the difference? Okay, if it is continuous delivery, okay, so the deployment is production to the production is manual. But if it is continuous deployment, delivery to the production is completely automated.
Yes.
So continuous delivery is not equal to deployment. Okay, so remember, deployment is automated. Okay, delivery is not. Understood, guys? So what are the various
Yeah.
CI/CD tools we have? Okay, so we have Jenkins, we have cloud-based Jenkins, Travis CI, Circle CI, even we have the GitLab CI, and then GitHub has its own GitHub Actions. Okay, and then we have the Bamboo, TeamCity. Okay, so we also have the GitOps tools. Okay, one is the Argo CD, Flux CD. Okay, Jenkins X, even this also supports a GitOps principle. And then AWS. So these are all the tools that some are open source or some are paid. Okay, in coming to the cloud vendors, right? So they have their own versions of source code management, their own versions of CI, their own versions of CDs. Okay, for AWS we have the code commit. Okay, so we have the code pipeline, a code build, so building the code, we have the code deploy, and we have the code pipeline. See here, all the terms are obviously same, but their offerings are different. Okay, so they are offering software as a service, right? So they're giving the software to be consumed. So these are the various AWS services when we talk about the complete CI/CD solution with the AWS. Okay, so these are all managed by AWS. So we hardly have much of the work to do. Okay, see here, we have the AWS code commit, which is acting like a Git repository. And then we have the AWS code pipeline, which is acting like a CI server. And we have the build. Okay, this is just like your build server. So this is code deploy. So this is like deploying your artifact to the machines or EC2 instances. It's a basic thing, but
Yeah.
all these are offered by the AWS. So if you want to know more, you can just click on this each one, and then you can work on it. Basically, these are very easy to learn. Okay. And we also have the GitOps. Basically, what is GitOps is, so for the source code we are using Git, right? So our complete source code is being version controlled in the Git. But what about the configuration files, like the Terraform files or the Ansible files or the Kubernetes manifest files or whatever files it may be related to the infrastructure or the application deployment? So no one version control them basically, right? So what GitOps says is, so Git should act like a single source of truth, not only for the source code management, but also for the infrastructure as a code, okay, files. So basically we are using Git to put all our source code, right? Like Python files or Java files, etc. Okay, what GitOps says is, so once you have the code, right, what generally we'll do, we have the CI pipeline. Okay, the CI and CD pipeline. So this will deploy your application into the uh, target environment, right? Okay, but what GitOps says is, in case of normal deployment, someone can go to this environment and then they can delete some resources or add some resources. He can do anything. Okay, one who has an access to the environment, right? So once someone is doing all these changes, right, to the environment or to the configuration, so it is not audited. That means that, so it becomes hard for us to identify who is the culprit, let's say. So in case of GitOps, what GitOps says is, you manage this complete infrastructure as a code, like how your infrastructure has to look like as a code. What are your deployment application deployment files or the configuration files? So what GitOps says is, you version control them, okay, and then have your environment, okay, sync with these configurations automatically using pull based. So you have the some sort of agents or bots. So they'll pull this configuration and they'll configure their environment automatically. Okay, let's say that someone who has an access, right? So they entered this environment and made some changes, let's say. Then what this agent will do is, agent will see that someone has done some changes, and whatever is the configuration that is there in the gate is not matching the current configuration. Then again it will try to pull the configuration, and then it will automatically revert this environment back to this particular state. That means that complete environment, complete application code is now version controlled here, and these agents will pull. That means that we don't have the CD pipeline anymore. Okay, so once CI process is completed, we'll update these configurations. Let's say after the CI process, the Docker image is nginx colon 22 is the latest image which you are generated from the CI pipeline. So now you trigger the CI pipeline in such a way that it will change the configuration in one of the configuration files here. So earlier Docker image tag is 21. Now you changed it to 22. Then this agent, right, in the environment, you will see that the configuration has changed in the gate. Then it will immediately update that current deployment to this particular Docker image. Okay, so this is known as
Okay.
GitOps, where configuration can also be version controlled, not only your source code. That's it for this video, guys. If you like our video, consider subscribing to our YouTube channel and joining our Facebook group. The links are given in the description below. You can also scan the QR codes being displayed in this video. And for any training requirements, you can join our Telegram channel where we post regular updates on our upcoming trainings. You can also WhatsApp us on the number being shown here. You can also drop us an email for any kind of training inquiries. Thank you.